In problem C, I have a sub 3 equals 5 and a sub 4 equals 8. So they didn't give me my common difference, but it's implied here because to get from a sub 3 to a sub 4, what are you doing? You're adding 3. So what that means is that your common difference D is positive 3. However, they did not give us our first term. We can figure it out, though, if we have our common difference in at least one other term. So what we'll do is we'll take, doesn't matter which one, I'm going to take the fourth term. You could take the third term, though. Well, let's take the fourth term, and what the formula says is take the first one and add and do n minus 1. Well, n minus 1, if our n is 4, our n minus 1 is going to be 3. So our n minus 1 will be 3 times your common difference, which is also 3. We just found that. So we'll have our 3 from our n minus 1 and our common difference 3, which will give us 9, equals our other side of the equation, which is the one we already know about, the a sub 4, which is 8. So to solve this equation, we solve it like a normal equation by subtracting 9 from both sides, and that would give us that our first term, a sub 1, must have been negative 1. Be careful, we're not done. What was the goal for this? It was not to find the first term, it was actually find the sum of the first 10 terms, s sub 10. Well, in order to find s sub 10, I need the first term. I just found that. And I need the 10th term. I still don't have that. So let's find the 10th term here. So how do we find our 10th term? Well, remember the formula says to find the 10th term, you take the first term, which we just found out was negative 1, and take the n minus 1. Well, if we're looking for the 10th term, n minus 1 is 9, times your common difference, which is, again, has not changed, is still 3. So we'll have our 9 times 3, which is 27, added to our first term, which was negative 1. Well, negative 1 added to that 27 gives us 26. So again, what does the formula tell us to do to actually find the sum? Is it tells us to take that n term we just got, the 26, and the first term, the negative 1, add them up and divide by 2. We're going to average those first. So we're going to do this part of the equation first. So we're going to add up the first one, negative 1, and the 10th term we found, the last one, 26, and divide by 2. But we got to do the addition first because we're averaging. Negative 1 added to 26 is actually going to give us something not so pretty, 25, divided by 2. But we're then going to turn around and multiply by the 10 that was out in front. So times 10, which is 10 over 1, can actually be reduced because we have a 10 on top and a 2 on the bottom. That will reduce just to the number 5. So we have a 5 times 25, which you may not know off the top of your head, but that's the same thing as 5 cubed, which is 125, which is what we got here. Let's look at this next example. On this next example, we want to find the sum of the first 120 positive integers. Well, first of all, let's get a picture of what this would mean. It would mean that we're going to add up 1, and then 2, then 3, then 4, up until all the way that we need to get all the way up to 120. That would be the first 120 numbers. So let's see. The first number of our sequence is 1. And the last, or 120th number would be 120. So what does the formula tell us to do? The formula tells us to take the first one, the 1, and the last one, the 120, and average them. Add them up and divide by 2. Again, that's not going to be a pretty number. So it'll be 120 plus the 1 will be 121 divided by 2. And then at the end, you'll multiply by the number that was out in front, the number n, which is that you are adding up the first 120 numbers. So multiplied by 120. Again, the 120, you can think of it as 120 over 1. You can reduce this because, let's see, the 120 and the 2 are both divisible by 2, and 2 will go into 120 60 times. And what that will mean is I'm actually multiplying the 121 and the 60, which will give us 7,260, which is what we got here as our sum. So that's what we got, the 7,260, and we're done. That's our sum of the first 120 positive integers.